When people think about working in tech, they usually picture somebody sitting on their laptop with millions of lines of code to run through, right? But honestly, most of what we do isn't about knowing everything, it's about figuring things out. Being in tech isn't about being the smartest person in the room. It's about being curious enough to keep trying, even when it doesn't make sense yet. So think about you solve everyday problems like troubleshooting your Wi-Fi, adjusting your computer, or organizing your files on a daily basis. You're already thinking like an engineer, but you just don't even know it yet. You test, you adjust, and you learn from what doesn't work and you try something new. Now, before I dive into how to think more like a tech guru, how to think more like an engineer, I really want to dive into what is computer science. And what it is at its core is a combination of things. It's all things tech, but it's more to it than that, right? There's also going to be logic and problem solving. That's the core of it. And yes, math is included in that. You don't need to be amazing at math, but you do need to understand that math is the reason we're here, right? But anyways, back to the computer science part of that. I've come up with this little pyramid of mine to really encapsulate what is a part of computer science. And the first one being programming. So programming is a big core block here because we see that with everything, it communicates with computers. That's what programming is. So if the computers aren't talking to each other, then, you're out of luck. Now, with that being said, our other base category here is IT systems, and that's what keeps technology running smoothly, right? Keeping those programs talking to each other. Now, when we move up the pyramid, we'll see that software engineering is another block, and that is building organized, scalable solutions, not just, scripts. It's something that actually comes together and makes more sense. And then the next part of this is data science and AI. And that is something that I'm sure many people have heard, especially in today's day and age with generative AI pretty much taking over. But this is a huge, huge part of computer science, especially the data part of it. And that leads me to the last one here, which is cybersecurity, which is protecting everything from, digital threats and hacking and all of those types of things. But all in all, just to like round it all off, everything takes curiosity and problem solving. Those two things are the core of it, is essentially what it is. Problem solving, right? I know I've said it a million times, but I just need people to understand that it's not some magical thing that, just appears. There are reasons for these things, and there's layers to it. Even as a programming language, there's different levels of programming languages. There's the ones that, you think of that a developer might have on their screen that looks more like plain English but is still a little bit hard to read. And then there's binary code, and that's just a bunch of ones and zeros that translate to a math equation to get you over to what it actually is trying to do with it, and associating it to numbers and words and letters. So there's so much deeper stuff to it. Anyways, back to the main topic, which is how to think like a tech engineer and what the tech ecosystem looks like. So the tech ecosystem as it is today looks a little something like this. Basically, we'll have our developers, the people within infrastructure, security, data science and AI, product leadership, and user experience, right? So all of these roles do end up overlapping, and they do end up having to work together. So it's important for you to understand how that all ties together, whether or not you're just going to decide to go into one section of this, or maybe like one of the developers here in the list and that's coming up will be like a full stack engineer where you're trying to do multiple different things. Either way, it's really good to know. And obviously it's not limited to this, but this is kind of the generalization, 6 categories that I came up with. So let's get into it. Starting off, we have our developers, and these are the ones who build tools, apps, and softwares that we use every day. You'll see the list of current roles that are out there and even some upcoming titles that might be emerging. In our next section here, we'll talk about infrastructure, and this is everything that keeps tech running: network, cloud, servers, everything that allows what the developers created to come to us. So, with that being said, we'll go on to our third category, which is security. And this one is what it is, right? It's all about security and keeping everything private and protecting our systems from attacks. The fourth category, being data science and AI, is something we're seeing a really big boom in right now, but you'll also see some of the roles that have already been around for quite a while in this list too, so feel free to pause and check this one out. The next category is product leadership, and this is what connects technical skills with practical use of said technical skills. And sometimes people who are very technically minded have a hard time seeing that, and somebody with a practical product leadership mindset comes in and helps balance that tech team. So these are what those roles are specifically about. Now, with the last category, we have user experience, and this is what, makes technology simple, usable, and human. So we have a lot of roles over here like UX engineers, and really just, again, focusing on how humans interact with the technology. So now that you know what types of roles are out there, what types of jobs are out there, how are you going to think like a tech guru? How are you going to think like an engineer? Well, the way that I do it and the way that a lot of people do it is in a simple 6-step process. That 6-step process involves finding out what the problem is, researching that problem, getting a plan for that problem in place and how you're going to solve it, actually building it, a testing phase, and then repeating it if you have to, right? Until you get that right. You just keep repeating that plan. I will say that half of my job is researching what I need to do. And when I say I love whiteboards and I love, my iPad for sketching out ideas, I'm serious. I need to see it out before I just start writing any lines of code. And so that is the true magic there, is again being able to figure out what the problem is and how you're going to solve it and how are we going to implement that. And that, again, is the bulk of the time. Actually implementing it, that's no problem, of course, unless you research something that was inaccurate, and you run into some issues and you have to do some more research. But that, again, turns into that repeating of plan, build, test, repeat. You keep that circle going, and you keep that faith that just because maybe you didn't get it right the first time doesn't mean you can't get it right the next time. Because I promise you, this industry moves so fast that you will never be able to know everything. You will never not be able to stop learning. You will always have to continue to stay curious, continue to research what's the best way out there, what is going to be the best for my case scenario, etc. And that's not a bad thing necessarily, because if you get really good at the problem solving, you don't really need to stress about what language it is that you're going to have to use or what program it is that you're going to use and be stuck to one system or one thing. Because if you already know that you can solve it, or you've proven that you can use this, all you got to do is switch syntax or research how this communicates with this, then you're golden. Which leads me to my next point, the big old debate of, do you need a computer science degree? Do you need a degree in tech? Do you need to have boot camps under your belt, etc.? And the answer to that is none of it matters and all of it matters. So I've seen people with degrees get jobs. I've seen people with degrees not get jobs. I've seen people who have never been to a college a day in their life and learned everything they know from YouTube, and they're the best, developers I've ever seen. But then I've obviously seen some self-taught coders that are not as great. So it really is dependent on the situation and who you are. And if you can prove that you can do it, then usually you can find work. But when it comes to, certain goals that that you might need a degree for, like if you ever wanted to be a doctor in computer science or something like that, or certain positions that require that, of course that'll be there. But that's not to say that um, work experience and proof of, intelligence and whatever it is you're, focusing on isn't something that can get you a long way too. So, if you're curious about getting into tech and you want to find more information or just hear tips about how to get into the industry, please follow, please like, and I'll see you next video.